Hello my dear students, welcome back to my class. In the series of learning data structures through C, in the previous video we discussed about the insertion algorithm. Well, in today's video we will discuss about the next operation on array data structure, which is deletion. We will see the algorithm of deletion with tracing. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Please watch the video till the end and do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Let us understand the tracing of this deletion first. So assuming you have an array already filled with 5 elements from A of 0 to A of 4. Now, what happens? If I want to remove a particular element in the particular position, I need to provide the position value. So if the position is equal to 0 means I am deleting the first element. If the position equals to n minus 1 means I am deleting the last element. If it is between 0 to n minus 1 means the position is in between. So this is for beginning and this is for ending, and this is in between. If I want to delete the first element, beginning element, the position is 0. Ending means, so where will be the last element? It will be in n minus 1. Say for example, I have given the n value as 5. So the last element will be in n minus 1. So it will be in A of 4. So if I want to delete the last element means the ending, the position is n minus 1. Then if it is in between means from 0 to n minus 1. So just imagine I want to delete this element. So what happens when I delete the element? First of all, the size of the array gets decreased. Just imagine you are standing in a queue. So you have few people standing in the queue. So I have the first person, second person, third, fourth and fifth. 5 people are standing in the queue. Suddenly, the third person wants to exit from the queue due to some emergency. So what happens here? So when the in-between person, or maybe in the first position or the ending position, if somebody exits, what happens? Just imagine the in-between person has to exit from the queue. Now, when the person exits from the queue, he will come out. The third person comes out. The position plus 1 person has to come to this position. Means 4 has to come here. Then again next 5 has to come here. This is how the shifting takes place. Means I need to start from the position and I need to do the shifting till I reach the last element. Position element will go out. Position plus 1 will come to the position. This goes on till I reach the last element. Means I am shifting the elements to the lower order. In the insertion operation, we shifted the element to the higher order. But here, we shift the elements to the lower order. Say, I want to remove this. 30 has to be removed. Now, 2 is the position. Position plus 1 means A of 3 has to come here. 40 will come here. Again, A of 4 will come to A of 3. So 50 will come here. And a copy will be there, but we'll cut off here. We will cut off here means we will print only up to here. The size of the array gets decreased. See, we shift the elements to the lower order. This is what? The deletion process. So if you have understood this tracing, let us see this with algorithm. So here we go with the algorithm. So we have the array filled with 5 elements. Say the n value is 5. 5 elements we have filled into the array. And I want to delete the element from the position 2, A of 2. So this element I need to remove. So I need to remove the element which is in the position 2. This element I need to remove now. Now, the first step says, step 1. So before I do the shifting, I need to take that element from that position. So what I do, I take the variable item and store the element that what I have in A of position. So, in the variable item, I get the element that what I have in position. Position means 2. So, what do we have in A of 2? It is 30. that I am going to store it in item. This is just for the reference at the end so that we can put an acknowledgement message saying that this item has been removed from the array. Next, the loop starts. As I said, I need to start from the position and I need to reach up to the last element. So the loop bound is set from I equal to p means I equal to the position value. The position value is 2. I need to start the shifting from the position up to n minus 1. So n minus 1 means n is 5. 5 minus 1, it is 4. So it is 2 to 4. So the array bound is between 2 to 4. In this bound, I need to do the shifting where position plus 1 value will be shifted to position. So I need to check this, is that within the bound? Yes, it is within the bound. Then execute this immediate statement. I say a of I means 2 equal to a of I plus 1 means 3. Means to say whatever the value I have in a of 3, that I need to shift to a of 2. Means position plus 1 value, a of 3 has to be shifted to position. So a of 3 I have 40, that I need to shift that to a of 2. So here what happens? Position plus 1 will come to position. That's what happens, right? Whenever someone exits from the queue, the next person will come to the position, right? So here 40 will come here. So here what happens? A of 3 will be shifted to a of 2. So here comes 40. Again loop back. So I need to move forward, right? So I has to be increased. So I gets increased. So it is loop back. I gets increased. It becomes 3. Am I within the bound of 3 to 4? Yes. Then shift the element from a of 3 equal to a of 4. That is a of I equal to a of 5 plus 1. I is 3. I plus 1 is 4. Whatever element I have in a of 4 has to come to a of 3. So a of 4 will come to a of 3. So you can just make out here the elements are shifted to lower order. In deletion, elements are shifted to lower order. In insertion, elements are shifted to higher order. Maybe all these questions could be asked in the Viva. See, when we do the insertion operation in the array, the elements will be shifted to higher order. When we do the deletion, the elements will be shifted to lower order. In the insertion, array size increases. In deletion, array size decreases. Insertion means increase. Deletion means decrease. Insertion, element shifted to higher order. Deletion, element shifted to lower order. So here, a of 4 will come to a of 3 means, what do we have in a of 4? It is 50. That will come to a of 3. Done. Next, again loop back. I need to move forward. So what will be the I value? It will be up to n minus 1, less than n minus 1 means I equal to 4 to 4. Yes, condition not satisfied. I don't go up to the last value because there is nothing, no more element to be shifted to the previous order. So I have to go up to n minus 1. So here the condition not satisfied. So I need, see, when I just move forward here, then I need to say a of 4 equal to a of 5. What do we have in a of 5? Nothing. So nothing to shift. Some junk value will be simply placed here. You don't get any error. Simply junk value will be shifted. That we don't want. So we will stop here and we have to come out of the loop. So we should come out of the loop. Then end of the for loop. The size gets increased and becomes 4. Then exit. So we will stop here and we will print these 4 elements. Well, this element will be there, a copy of that will be there, but we are not going to touch that, we are not going to print that. We will print up to 0 to 4 means less than 4. 0 to less than 4 means 0, a of 0, a of 1, a of 2 and a of 3. So hope you have understood with this deletion algorithm. The next video, we will see the program of this with execution. So stay tuned to my channel. That's all for today's video. See you in the next video. Till then, take care. Bye-bye.